Hello everyone, welcome to my YouTube channel MechE-FUNdaMENTALs. In this video, I will discuss the working of U Tube manometer. So in the series of Fundamental of Mechanical Engineering, the topic is U Tube manometer, and I discuss the construction of U Tube manometer, working principle of U Tube manometer, and some numericals to understand the concept. Now the first is the construction of U Tube manometer. So a manometer is a device used for measuring the pressure of gases and liquids. It consists of a glass tube of U shape. If you see the diagram, so this is the glass tube and you see the construction that is of the U shape. So that is the reason why it is called as U tube manometer. And in this U tube, partially filled with a liquid which is known as a manometric fluid, and generally it is used, mercury is used. You see here. So this red portion, this is the manometric fluid, and generally or often we use mercury as a manometric fluid. And one end is open to the substance whose pressure is being measured. So you see this is the right leg of the manometer and that is the left leg of the manometer. So one end of the manometer, if you see, that is the left end, that is connected with a pipe or the substance whose pressure actually you have to measure. Now you see, if we talk about how that manometer works, so we can simply understand with the help of this diagram. The liquid in the manometer respond to change in pressure by rising or falling within the tube, and this change in liquid level is used to determine the pressure of the substance being measured. If you see the first diagram, P1 and P2 both are equal. The pressure in its right leg and the left leg both are same. P1 that is equal to P2. Now you see the level of the mercury or the manometric fluid in both the sides, that is same. It means the pressure are same, then we have no difference of the level of the mercury or the manometric fluid in the right leg or the left leg. Now you see the second case where P1 is greater than P2. So the pressure in the left side is more than the right side. So you see what happened. The level of the mercury, that is different. You see the level of the mercury in the left leg is this and the level of the mercury in the right leg is this. So we have the difference of the level of the mercury. You see this difference we are getting. So why we are getting this difference? Because we have the pressure difference. So P1 is greater than P2 and that pressure difference actually gives the difference of the level of the mercury. So here the level goes down in the left leg and here in the right leg the level goes up. And why it is so? Because the pressure P1 it is greater than P2. Now P1 is less than P2, that is also possible, that depends. So what happens now? You see the level of the mercury on the left leg and the level of the mercury in the right leg. So again we have the difference of the level of the mercury in both the legs. But here what is the difference when we are comparing with this second case? Now here in the right side the level of the mercury goes down and in the left leg the mercury goes up. Why? Because the pressure P1 is less than P2. Okay, so we have the three possibilities. Either the pressure is same both the sides, then the level of the mercury is same. If we have the difference between P1 and P2, so definitely we will get the different level of the mercury in both the legs. Now if you talk about the principle of U tube manometer, so manometer measure a pressure difference by balancing the weight of the fluid column between the two pressure of interest. Okay, now we understand with this diagram. So this P0, this is the atmospheric pressure. Okay, so this right leg is open to the atmosphere and the left leg that is open to an unknown pressure source. Let us suppose here we are using gas as a medium. So P is the pressure of the gas and that pressure is attached with the left leg. Okay, now you see what happens. This is the level of the mercury in the left leg and this is the level of the mercury in the right leg. So we have the difference and that difference is H. Okay, so with this diagram it is very clear that the gas pressure is more than the atmospheric pressure, because here the level of the mercury goes down and here the level of the mercury goes up. Okay, so it means now this is the pressure P which is acting here. Okay, so due to that pressure which is more than the atmospheric pressure, we get the displacement of the mercury level in both the sides. Okay, so now to better understand, I will go to the next slide. If you see here again, so you see this level of the mercury, and again you have to see the same level of mercury in the right leg. So here in the left leg, I take a common line, or you say I take the same level, I draw a line this. So I talk about the same level in both the legs. So here the pressure is P, that is the pressure of that gas, okay? And at this particular plane or the surface, we have the two pressure, the one that is the atmospheric pressure, and the second that is the pressure due to the weight of this column. And according to the hydrostatic law, the pressure of this particular column, that is given by rho GH, that is rho GH. What is rho? That is the density of this manometric fluid, that is I am giving the symbol rho m. Okay, so rho m GH, that is the pressure exerted by this column in this particular plane. So the total pressure here, that will be P naught, that is the atmospheric pressure, plus the pressure due to this particular column, that is rho m GH. Okay, so now at the same level the pressure will be equal. So here we get this equation, this P, this is the P absolute because I am giving the pressure with respect to the absolute zero. So P equal to P naught plus rho m GH. So this equation we will get. Okay, so P is equal to P naught plus rho m GH. So in the same level, here the pressure is P and here the pressure is P naught plus rho m GH. Okay, so this P is the absolute pressure. So when we take P minus P0, it means this is the pressure with respect to the atmospheric pressure, and that pressure is known as the gauge pressure. Okay, this is the P gauge. So that is rho m GH. Okay, so by knowing the difference of the level of the mercury H, we can easily find out the pressure, that is the gauge pressure. Okay, because the density of the manometric fluid, that is the mercury, that is known to us, that is 13.6 into 10 to the power 3 kilogram per meter cube. G is 9.8, and H that we can measure by the difference of the level of the mercury. So that is your interest. Either you have to find out the absolute pressure or the gauge pressure. Okay. Now this is the second example. So here in the second example, now we have to measure the pressure of any liquid. The first case, that is of the gas. Now here we have a liquid. You see the lighter portion, that is the liquid, whose pressure we have to find out. That pressure is PA, that is a pipe. So this left leg of the manometer is attached with that pipe in which a liquid is flowing of a pressure PA. Okay, and this darker portion represents the manometric fluid. Okay, so let us suppose I take rho L is the density of this liquid in the pipe, and rho m, that is the density of the manometric fluid, and P naught, that is the atmospheric pressure. Now again you see the level of the mercury. Okay, you see this is the level I am considering. So you see the level of the mercury in the right side, that is goes up, and in this side that goes down, and this is because the pressure PA, that is more than the atmospheric pressure. So the pressure of the liquid is more than the atmospheric pressure, then we are getting this level of the mercury in both the sides. Okay, so again I take this as a reference plane or line. You see the pressure at this particular left leg in this particular plane. Okay, so PA is the pressure. PA is the pressure of that liquid in the pipe, and rho L GH1, that is the pressure due to this particular liquid column. So this liquid column height, this is H1, the density of the liquid, that is rho L. So rho L GH1 is what? That is the pressure exerted by this column of the liquid at this particular area, and PA is the pressure of the liquid in the pipe. So here the total pressure, that will be PA plus rho L GH1. Okay, now we see the pressure at the same level in the right leg. So here the pressure is P naught, is the atmospheric pressure, and the pressure exerted by this particular column of height H2, and this is the manometric fluid, and due to this particular column, the pressure exerted at that particular plane, that will be rho mg H2. So the total pressure here at this particular plane, that will be P naught plus rho mg H2. So now the pressure, that will be same in this particular level on the right leg as well as the left leg. So we are getting the first equation, that is PA plus rho L GH1, that is the pressure on the left leg on this level, and the P naught plus rho m GH2, that is the pressure in the right leg on the same level. Both are equal. Okay, so PA, that is equal to, so now we take this particular term on the right side. So PA, that we get the absolute pressure, that is P naught plus rho m GH2 minus rho L GH1. If I take the atmospheric pressure on the left side, So I will get PA minus P naught, and that is the pressure of the liquid with respect to the atmospheric pressure. That is a gauge pressure. So that is rho m GH2 minus rho L GH1. Rho m, that is the manometric fluid density. Rho L, that is the density of the liquid. G is the 9.8. So simply by knowing the value of H1 and H2, we can find out the gauge pressure as well as the absolute pressure as our requirement. Okay. Now you see, this is the first numerical which I discussed here. So a manometer is used to measure the pressure of a gas. So this is the gas. That is the first case. The fluid used has a specific gravity of 0.85. That is the manometric fluid whose specific gravity is given. So specific gravity means its density will be 0.85 times of the density of water. So the density of that particular fluid will be 0.85 into 10 to the power 3 kilogram per meter cube. And the manometer column height is 55 centimeter. You see this 55 centimeter, that is the difference of the level of that particular manometric fluid. Okay. So this pressure actually we have to find out. And if the local atmospheric pressure is 96 kilopascal, this is the atmospheric pressure. And this pressure will exert here because that is open to the atmosphere. Okay. And we have to find out the absolute pressure. So here again, in this case, I take the level of the mercury like this. Okay. Now you see the level of the mercury goes up in the right leg. So definitely this gas pressure will be more than the atmospheric pressure. So here the pressure exerted at that particular plane, that will be P. Okay. And in the same level on the right leg here, the pressure will be the atmospheric pressure, that is P atmospheric, which I am taking the P dot, plus the pressure exerted by this column. Okay, that is rho GH. Rho is what? That is the density of the manometric fluid, rho m. G is 9.8 and H is that particular distance or the height. Okay, so P naught, that is the atmospheric pressure, that is 96 kilopascal. Okay, so we convert into Pascal, that will be 96,000 Pascal. This is the first term. And plus rho m, that is the density of that particular manometric fluid, because the specific gravity is given. So we have to multiply with 10 to the power 3. So 0.85 into 10 to the power 3, that is the density of that particular manometric fluid, kilogram per meter cube. G is 9.8 and H, that is in centimeter. So we convert into meters, so that is divided by 100, that is 0.55. So when we solve this, we get, this is the value in terms of Pascal, that is 100,581.5, that is in Pascal. So divide by 1000, we are getting in kilopascal. So the absolute pressure of the gas will be 100.5815 kilopascal. Now see, this is the second case. Here we have to find out the pressure at point B with this U Tube manometer, where rho L is the density of the light liquid and rho 2 is the density of the heavy liquid. So again, that is the case of the liquid. So this is the liquid whose pressure we have to find out. Rho 1, that is the density of this liquid. This is lighter liquid actually. Manometric fluid whose density is more generally with respect to the liquid. So that is rho 2. Now we have to find out the pressure at point B. Okay. Now you see here in this case, this level we take actually. Now you see the mercury or the manometric fluid displacement. So this manometric fluid goes up in the left leg and that goes down in the right leg. Why it is so? Because here the pressure is atmospheric. If I say P atmospheric, okay, so it means the pressure of the liquid is less than the atmospheric pressure. So atmospheric pressure is more than the liquid pressure. So definitely that is a condition of vacuum when the pressure is less than atmospheric pressure. So here the mercury level goes down and here the mercury level goes up. And that is the reason for that, because the atmospheric pressure is more than the liquid pressure. So if we take this particular level, so we talk about the pressure at that particular plane in the left side as well as in the right side. So what is the pressure in the left side at that particular plane? So that is PB is the first term, that is the pressure of that liquid, plus the first one, that is the pressure exerted by this particular column, and plus the pressure exerted by this column. So this H1, that is the height of that liquid, and this H2, that is the height of that manometric fluid. So rho 1 is the density of this liquid and rho 2 is the density of this liquid of height H2. So that will be rho 1 GH1, that is the pressure due to this particular column, plus rho 2 GH2, that is the pressure exerted by this particular column at this particular plane. So here the pressure will be PB plus rho 1 GH1 plus rho 2 GH2, and that is equal to the pressure at that particular plane in the right side. And here the pressure is atmospheric. Okay. So PB minus P atmospheric, this is the gauge pressure if we talk about. So that will be minus, because these two terms will go right. So we have the negative sign. Okay. Minus in bracket rho 1 GH1 plus rho 2 GH2. Okay. So what is the meaning of this minus sign? Minus or negative sign indicates that the gauge pressure is vacuum pressure. So that already I told you, because the level of mercury will give you the information about the pressure difference, which is more actually. So here the atmospheric pressure is more than the pressure of the liquid, so that is the condition of the vacuum pressure. Hope this particular video will helpful you to understand how the manometers are used to determine the pressure of any liquid or gas. Okay, thank you.